Hi everyone in Algebra 3. Today we're going to be going over the new material in lesson 76. This is going to be more on proofs. So there's a lot of information that you're actually going to need from this lesson. So what I would do is I would probably pause the video on each of the slides so that you are able to take some notes on some of the functions that are equal to each other. And so first off, we have the sign of a negative function, or the cosine and negative. So each of these are just the sine, cosine, tangent, cosecant, secant, and cotangent of a negative degree and what that does to the function. So notice that the negative sign for this one makes it the negative sine function. This one's just a positive. Tangent becomes negative. So the only one that stays positive, or even with the negative degree, would be cosine and secant. Now looking at the functions of the other angle. So if you have sine of x is equal to a over c, the cosine of 90 minus x is actually going to be equal to a over c equal also. So cosine means the sine of the other angle. Cotangent means the tangent of the other angle. Meaning that you need to know all of these. So cosine of 90 minus x is equal to sine x. Sine of 90 minus x is equal to cosine x. Tangent of the opposite angle is equal to cotangent x. And then it's the same for the others. And we're going to be using all of these in proofs. So that's why you need to know it. These are some trig identities, which you definitely are going to need to memorize eventually. I wouldn't say you need to memorize them for this year, but definitely for next year if you're moving on to pre-calculus. So the two forms of expressions that have identical values. So cotangent x is the inverse of tangent. Secant is the inverse of cosine. Cosecant is the inverse of sine. And then tangent is sine over cosine. And cotangent would be cosine over sine. So now what I'm going to do is I'm going to show you how to do these proofs using all of those identities. We're going to do numbers 6, 7, and 8 together. And then what I would like you to do is I want you to work through numbers 16 through 30 with me. But I would like you to attempt the problem before actually pressing play and doing the problem with me. So that would help you get a good start on your lesson. So for number 6, you're going to start with the left and then you want to end up with the right. So you start with the left, want to end up with the right. So I'm going to start with cosine x, tangent x. Well, based off of my notes, I know that tangent x is equal to sine x over cosine x. So I'm going to replace that. That's going to be cosine x times sine x over cosine x. So now my cosine x are going to cancel. Now what we can do is we actually know that the inverse of sine x, this would be the same as doing 1 over 1 over sine x. So if I multiplied it by the reciprocal, it would just be sine x. And now we know that the inverse of sine x, based off of this last slide, the inverse of sine x is equal to cosecant x. So this would be equal to 1 over cosecant x. So now your left is equal to your right, and that's what you wanted. So you always start off with the left and then you're going to end up with the right. So now let's look at number 7. So number 7, I'm going to start with the left. I want to end up with the right. So for 7, I have cotangent x over cosecant x. Oops. Now cotangent, I'm going to use these identities here. cotangent is equal to cosine over sine. So I'm going to do cosine x over sine x. And then I know cosecant x is the inverse of sine, so that would be 1 over sine x. Now, because this is a complex fraction, I'm going to multiply by the reciprocal, which would be sine x over 1. So sine x's cancel, and I am just left with cosine x. So after that process, the left is equal to the right, and that's what you need. Then for the last one, number 8, we are going to have negative sine of negative theta cosine of 90 minus theta, and we want it to be equal to sine squared theta. So what I'm going to do is I need to flip to my first slide, which told me that the sine of a negative value is equal to negative sine. The sine of a negative value is equal to sine. So that means this is going to be negative sine theta. So this is going to be negative sine theta with the minus sign outside. Then I'm going to flip to this slide, which says the cosine of 90 minus x is equal to sine x, which means this right here is equivalent to sine theta. Now, two negatives make a positive. So that means this is going to be equal to sine squared theta. So the left is equal to the right. And that's what these proofs are. So now what we're going to do is we're going to go through numbers 16 through 30. And again, I want you to be doing the problem first and attempting it first, then unpausing it and doing it with me so that hopefully you are kind of learning from this. So let's start on number 16. A parabola has its vertex at -3, -2, and its focus at -3, 5. So for number 16, I'm going to start with my diagram. Which is not going to be big enough. So 1, 2, 3. 1, 2, 3, 4, 5. So this isn't really going to fit, but so -3 up down 2 is going to be your vertex. Your focus is at -3 up 5. So I know that my parabola is going to open up towards the focus. This is going to be my axis of symmetry, where your vertex and your focus line up on the x-axis, which means your axis of symmetry is going to be equal to x equals -3. Now, I need to find my directrix. So I know that between my vertex and my focus, there's 1, 2, 3, 4, 5, 6, 7 spaces, which means that the distance between the vertex and the directrix is also going to be 7 spaces, but in the opposite direction. So that's 1, 2, 3, 4, 5, 6, 7, which I know it runs into my other problem, but that would be about here. So that means my directrix is crossing the y-axis at -9. Now what I need is my equation of my parabola, which is going to be y is equal to 1 over 4p times x minus h squared plus k. So h and k are just going to be the coordinates of the vertex. This p is going to be the distance away from the vertex to the focus. And again, that's 1, 2, 3, 4, 5, 6, 7 spaces in the positive direction. That means that my p is going to be equal to 7. Then I have x minus negative 3 squared plus negative 2. Thus my answer is going to be y is equal to 1 over 28 x plus 3 squared minus 2. So that's going to be your equation of your parabola. You already had your axis of symmetry and directrix. And you have your diagram. Now what we're going to do is we're going to do number 17. So now for number 17, what I'm going to do is I'm going to convert this. So this is going to be x is equal to 2 to the positive y. I'm going to plug in -1, 0, and a 1. 2 to the -1 is going to be 1/2. Then 2 to the 0 is going to be 1. Then 2 to the 1 is going to be 2. So now these are just my temporary points, because remember that when the function becomes negative, when the entire function becomes negative, it's going to mirror on the x-axis. So I have 1, 2, 2. So I'm going to go over 1/2 down 1, over 1 up 0, then over 2 up 1. But if I'm going to mirror it, that means instead of this being here, you're going to mirror it to this point here. This doesn't mirror, but this would mirror to this point here. So it just mirrors across the x-axis, and then you're just going to connect the dots here. And that would be your graph. So I just mirrored it across the x-axis for number 17. Now moving on to number 18, what we're going to start by doing is we actually notice that all of those terms are divisible by 2. So I'm going to divide the whole thing by 2 before splitting it up. When I split it up, I'm going to put the x's together. So that would be x squared minus 2x plus y squared plus 2y. That's going to equal to 2. Now when I complete the square, I take half of the -2, becomes -1 squared. I'm going to add 1 to both sides. Half of 2 is going to be y plus 1 squared. I'm going to add 1 to both sides, which is going to be equal to 4. So that means the coordinate for the center of the circle is going to be 1, -1. And the radius is going to be equal to 2 because it's the square root of the right-hand side. So now I'm going to diagram this. So I'm going to go over 1, down 1 is the center of the circle. The radius is 2. So up 2, to the right 2, down 2, and to the left 2. And this should be your circle. Now moving on to number 19. So number 19 is going to be our sine function. It says write the equation as a cosine function. So if we look at this one, I'm going to write this as a positive cosine function. And I want you to take a look at what that looks like. So this is our function. We want it to be a positive cosine function. Remember, for a, you start by adding the top and the bottom and dividing by 2. So that would be 9 plus -3 divided by 2. Then for b, it's going to be the top minus whatever you get for a. Then for c, it's in degrees. So it's going to be 360 divided by the length of the period. And the length of the period in this case, we're going to calculate from -270 to 270. So that circles down, circles through the x-axis, and ends here. So the distance, the length of the period, will be just 270 plus 270. So now I'm going to evaluate. So I have 9 minus 3, which is 6, divided by 2 is 3. 9 minus 3 is going to be 6. Then I have 270 plus 270 is 540. So 360 divided by 540, written as a written as a fraction, is actually just 2/3. So now my answer so far is going to be y is equal to 3 plus 6 cosine of 2/3. And this is the phase shift. So currently it is peaking at 135 degrees, and I want it to peak at 0. So I would have to shift this whole thing 135 degrees to the left. So again, it's peaking at 135. I want it to peak at 0. So I'm just going to shift this whole thing over 135 degrees. So my phase shift would be theta minus 135. So essentially what you're doing is you're just inputting where it's peaking. And it's always theta or x minus that degree. So wherever it's currently peaking is what your d is going to be equal to. Now looking at number 20. So for number 20, we're going to write the equation, the sinusoid whose graph is a sine function. So this is number 20. It's going to be y is equal to a plus b sine c theta minus d. And I'm going to go through and input what I have. So the phase angle is -30, so that would be x minus -30. They said the period length is 90, so that's always 360 divided by the length of the period, which is 90. And they give us what b is equal to, the amplitude of 3/2, so that would be 3/2. And my a is -3. And now all you have to do is simplify that, which means that we would just divide the 360 by 90. So that would be y is equal to -3 plus 3/2 sine 4x plus 30. And that would be your result for number 20. Now looking at number 21, what you're going to do first is you multiply the outside numbers and then you add the degrees together. So in this case, we would have 6 times 3, which is 18. CIS, when I add those together, 13 minus 7 would be 6. And 6/8 would be 3/4. Now we do need to expand that. So that would be 18 times cosine of 3π/4 plus I sine of 3π/4. So I'll need to make a snowflake chart for 4. So that would be 1, 2, 3, 4, 1, 2, 3, 4. When you start counting at 0, this would be 1, 2, 3. Sorry, 1, 2, 3. That's a 45-degree triangle in quadrant 2. So -1, 1 root 2. Now I'm going to do 18 times the cosine of that triangle, which would be -1 over root 2. But we can't leave the root 2 in the denominator. Then plus opposite over hypotenuse, which would be 1 over root 2. Move the root 2 to the numerator. And then you have I. So 18 divided by 2 is 9. So that's going to be -9 root 2 plus 9i. Nope, 9 root 2i. Okay. Looking at number 22. I'm going to start by moving the 1 to the other side. So this would give me cosecant squared is equal to 1. To get it so that the cosecant is no longer squared, I'm going to square root it, which means that I'm going to get cosecant x is equal to plus or minus 1. I'm going to separate that into 2 separate functions. So cosecant x is equal to 1. And then cosecant x is equal to -1. And I'm always going to put that over 1. These are both going to use the unit circle. Cosecant is equal to the inverse of sine, so that would be 1 over y. So for this one, I'm looking for where y is 1. For this one, I'm looking for where y is -1. So I'm going to underline all of them. So again, I said I'm looking for where y is +1 and then where y is -1. So this is +1 and this is -1. So I have x is equal to 90 and then x is equal to 270. Now on to number 23. So for number 23, I'm going to start by moving the 1 to the other side. So I have 2 cosine 4 theta equals -1. Divide by 2. So I'm looking where cosine is going to be negative. So all students take calculus. I know everything is positive in quadrant 1, and then cosine is positive in quadrant 4. So my triangle is going to be in quadrant 2 and 3, so -1, 2. This angle right here is going to be a 60-degree angle. So what I'm going to do now is I'm going to set 4 theta equal to 180 minus 60, which would be 120. And then set 4 theta equal to 180 plus 60, which is 240. So my first answer is going to be theta is equal to 30 degrees. My second answer is going to be theta is equal to 60 degrees. So now what we are going to do is I have to find out my other 3 answers for each. So I'm going to set 4 theta equal to 360. When I divide by 4, that's going to give me 90. And this is what I'm going to continuously add until I end up with 4 answers for each quadrant. So 90 plus 30 would be 120. 120 plus 90 would be 210. And then 210 plus 90 would be 300. 60 plus 90 would be 150. 150 plus 90 would be 240. And 240 plus 90 would be 330. And these would be your 8 answers that will satisfy number 23. Now let's look at number 24. So number 24, what I'm going to do first actually is to set all my cosines equal to just the variable z, because I have to factor this. So that would turn this into z squared plus 4z plus 3 equals 0. Now that actually factors out evenly. I have z plus 3 times z plus 1 is equal to 0. So I have two answers. I have z is equal to negative 3, and then z is equal to negative 1. And now what I'm going to do is I'm going to replace all my z's now with cosine. So it would be cosine x is equal to negative 3, and then cosine x equals negative 1. Now what I should recognize at this point is that there's no place where cosine is going to be equal to negative 3. So this is not going to work. The only one I'm going to be solving for is the one on the right, and that's going to use the unit circle. And I'm looking for where my x coordinate is equal to negative 1. So underline all my x coordinates. The only negative x coordinate that's equal to negative 1 would be at 180 degrees. So after factoring, you notice that one of the equations just does not work because there's no way where cosine is equal to negative 3, and that's why we didn't have to do that one. Now looking at number 25, we have the tangent squared root of negative 510, secant squared root of negative 510, sine squared root of negative 510, and cosine squared root of negative 510. So negative 510 degrees is greater than 360, so we're going to add 360 to that. And you're going to get negative 150 degrees. Negative 150 degrees is going to be in quadrant 3 with a 30-degree angle. So that'll be negative root 3, negative 1, and 2. So the tangent of this triangle would be opposite over adjacent. And that will just give me 1 over root 3. Then for secant, it's hypotenuse over adjacent, which would be 2 over negative root 3 squared. For sine, it's opposite over hypotenuse, so that would be negative 1 over 2 squared. And for cosine, it's adjacent over hypotenuse, which would be negative root 3 over 2 squared. So when I square 1 over root 3, that's just going to be 1/3. When I square the second one, it's going to be 4/3. When I square 1/2, I'm going to get 1/4. And when I square negative root 3 over 2, I get 3 over 4. So 1/3 minus 4/3 would be negative 1, and 1/4 plus 3/4 would be 1. Which means my result for number 25 is equal to 0. I just realized that for numbers 22 through 24, we're supposed to do that in radians, but because I did it in degrees, I'm not going to go back, so you can go ahead and leave your answer that way. Now moving on to number 26. What I'm going to do first is I have to solve my equation for y. So that would be 2y equals negative 3x plus 10. Divide that whole thing by 2. So you should get y is equal to negative 3 over 2x plus 5. The point that we're looking at is 2, 3. So step number 1 is to find the equation line that's perpendicular to this line. So that would be y equals 2/3 x plus b. I'm going to plug in this point right here, which is going to be y3 equals 2/3 times 2 plus b. Then what I need to do is I need to make a common denominator. So that would be 9/3 minus 4/3 equals b. So b is going to be equal to 5/3. So my equation of my perpendicular line that goes through the given point is going to be y equals 2/3 x plus 5/3. Now for step 2 of this problem, you're going to set your original y equal to your new perpendicular y. So that would be -3/2 x plus 5 is equal to 2/3 x plus 5/3. And I'm going to multiply this whole thing by 6 to get rid of the denominator. So that would be -9x plus 30 equals 4x plus 10. So move the 9x over, move the 10 over. 20 equals 13x. So x is going to be equal to 20/13, which is not very helpful. But step number 3 then is to solve for what y would be equal to. Let's just plug it into the top equation. So that would be -3/2 times 20/13 plus 5. 2 goes into 20 10 times. I can make a common denominator of 13, which means I have -30/13 plus 65/13. And that would give me 35/13. So now what I'm going to do, I'm going to move that. No, I will just cover it up. Is I need to do the distance formula. Distance formula is going to be the square root of x1, which is 2, minus x2, which is 20/13 squared, plus y1, which is 3, minus y2, which is 35/13 squared. Make a common denominator. So that would be 26 minus 20 would be 6/13 plus 39 minus 35 would be 4/13. So that's going to give me 36 plus 16 all over 169. And that would be the square root of 52/13. And then the square root of 52 would simplify to 2 square root 13/13. And that would be your result. So that is a long problem, number 26. Tedious, long problem to get to 2 root 13/13. Now we're going to look at numbers 27 and number 28. So for number 27, I see that there's a plus sign between my two logarithms. So to combine them, I'm going to multiply, which means that for number 27, I would get log 7 x plus 1 times 2x minus 3 equals log 7 for x. We can raise both sides to the power of 7 to get rid of the log 7. Then I need to multiply this through, so this would be 2x squared minus 3x plus 2x minus 3 minus 4x is equal to 0. So that would be 2x squared minus 5x minus 3 equals 0. And now I'm going to do quadratic formula to solve. So negative b plus or minus the square root, negative 5 squared minus, that's not going to fit, so 4 times 2 times negative 3, all over 2 times 2. Two negatives are going to make a positive, so 5 over 4 plus or minus the square root of, so that would be 4 times 2 times 3, 24 plus 25, which gives you the square root of 49, which is 7 over 4. 5 plus 7 is going to be 12 over 4 is 3. And then 5 minus 7 would be negative 2 over 4, which is negative 1/2. If I go back to the original equation, though, I need to make sure both of these work. But if I plug in negative 1/2 into here, 4 times negative 1/2 would be the log of a negative. You cannot do that. So my only answer is going to be that x is equal to 3. Now looking at number 28, if you see a number outside your logarithm, it is going to become the exponent, which means that we have log 1/2 of 16 to the 1/4 minus log 1/2 of x to the second equals 3. Because there's a minus sign, we are going to divide. So that would be log 1/2 of 16 to the power of 1/4 is 2. So that would be 2 divided by x squared equals 3. I'm going to raise both sides to the power of 1/2, which would then give me 2 over x squared is equal to 1/8, because 1/2 to the power of 3 is 1/2 times 1/2 times 1/2. Cross multiply would give me x squared is equal to 16, which means that x is equal to 4. Now for number 29, we have 2 parts to this problem. So again, if there's a number outside my logarithm, it is going to become the exponent. If there's already an exponent, you multiply those exponents together. So this would turn into ln e to the negative 2 to the power of 5 minus log 10 to the negative 3 to the power of 4 plus log 10 to the 5th to the power of 2. So we multiply those. So that'll be ln e to the negative 10th minus log 10 to the negative 12 plus log 10 to the 10th. Now the ln and the e, the log and the 10, log and the 10 cancel. So you're left with negative 10 plus 12 plus 10, because 2 negatives make a positive. The 10s cancel, so your result is just 12. Now for part 2 of this problem, similar, you're going to multiply the exponent by the current exponent. So this would be ln e to the negative 1/3 times 5 minus log 10 to the 1/6 to the 10th plus ln 1. Okay, anything to the power of 0 is equal to 1. So this is actually e to the 0. That's how it's going to cancel. So now I have ln e to the negative 5/3 minus log 10 to the power of 5/3 plus ln e to the 0. So I needed to change the 1 so that it had a base of e, and anything to the 0 power is equal to 1. Now my ln and my e, my log and my 10 and my ln and my e cancel. So I'm left with negative 5/3 negative 5/3 oh, that should not be negative. Wait, yeah, it is. No, it's not. This should have been this should be positive, my bad. So 5/3 minus 5/3 and then plus 0. So your answer is 0. Sorry, I messed up. That should have been a positive 1/3, not a negative 1/3. And now lastly, number 30, we're just going to be using our calculator for this problem here. So, and just remember that you're writing it to 4 decimal places instead of just your normal 2. So anti-log means you're solving for the number when the base is 17 and the exponent is 1.88. So you're going to do 17 to the power of 1.88, and you are going to get for A 205.7046. For B, we're going to do 7 to the power of 1.88, and you get 38.7958. And that concludes all the problems we're going to do for lesson 76. I hope that got you started, and I hope you did attempt them before you actually did them with me. And now you just need to complete the rest of them to get your stamp for lesson 76. I hope you guys all have a great day. Bye.